All right, so let's get started, everyone. Good evening, and welcome to today's webinar on shutdown optimization using BIM and digital twin for industrial owners and operators. Thank you for taking the time to join us. This session is designed to address the real world challenges industrial owners and operators face during shutdowns and how digital tools like digital twins and BIM can provide clarity, improve coordination, and drive smarter decision making. Moving on. Before we begin, a quick introduction to Digital. We are a digital transformation and BIM consulting company helping in businesses across the industrial, infrastructure, and real estate sectors streamline operations using advanced technology. Our core capabilities include LiDAR, remote sensing, and GPS integration, aerial data capture using drones, prefabrication planning, building information modeling for BIM, building and automation systems, and virtual reality applications. Each of these services is focused on improving efficiency, visibility, and control throughout the project lifecycle. We work with a wide range of tools and platforms including Autodesk, Bentley, Trimble, Adobe, Revit, Blender, and many more, allowing us to adapt to the specific needs of each client and project. Our service offerings are from virtual design and construction to IT and automation for the built environment. Through this integrated approach, we help clients drive digital adoption, reduce inefficiencies, and manage complexity at every stage. It's my pleasure now to introduce our speaker for today, Bremy, our BIM expert at Digital. Bremy has over 7 years of experience in the construction industry, specializing in large-scale infrastructure and industrial projects. He is well versed in implementing ISO 19650 compliant BIM strategies, developing digital twin solutions, and leading multidisciplinary coordination across teams. His work focuses on using technology to enhance collaboration, streamline workflows, and drive digital transformation across project life cycles. With that, let's get started. Demi, over to you.
Thank you, Bhuvi, for that lovely introduction. Good day, everyone. Thank you so much for joining this session. Before jumping right into the discussion, I wanted to dissect this topic because it's a huge one-liner which we have given right over here. Because these are different keywords which need to be addressed first, starting from shutdown. I'll be speaking on shutdown specific types, what are the causes of it, ways I can mitigate unplanned shutdown specifically, how owner operators, what are their issues which they face, how they can adopt certain technologies to help in their day-to-day activities, and of course, how through or how they can leverage BIM, which is simply a process that is enabled and powered by various digital tools. Coming to shutdown, now I'll give you a brief on what shutdowns are, what its purpose is, or what is its disadvantages, that sort of stuff. So what's the purpose of such a temporary or a halt? It can be to ensure safety and compliance, maybe perform critical maintenance or overhauls. Maybe it can be to upgrade existing infrastructure or equipment, or it can also be a response to a system failures, or it can be an emergency. Now coming to the different types of shutdown, it can be broadly classified as a planned shutdown as well as an unplanned shutdown. So a planned one can be for for turnarounds or overhauls, but an unplanned one can be due to an equipment failure of some sort. And a different one, it's maybe you can say it's the last one is for it being an emergency shutdown, which can be triggered by an in-plant or in-house plant safety system. Now, what specifically happens in a shutdown? Now, why unplanned shutdowns tend to compromise certain things. So broadly, shutdown activities typically comprises of equipment disassembly and inspection, or it may be cleaning and testing of certain systems, replacing certain or upgrading components, and it can also be for compliance audits and checks also. Coming down to the causes of shutdown. So industrial shutdowns, whether it's planned or unplanned, can be triggered by a variety of causes. Maybe we'll just quickly glance through each and every one of them. First being obviously the equipment failure, which can be attributed like for aging or poorly maintained machinery that can break unexpectedly. This clearly shows the lack of uh, predictive maintenance or real-time monitoring, which is not present, can contribute to such surprise failures. Uh, then safety incidents, which can be anything ranging from accidents to uh, fires or even chemical spills in chemical factories, which may require immediate shutdown. So that's basically an unplanned one. It helps in preventing harm to personal or any environment or even machinery. Then you have the obvious one, the repair and maintenance one, which can be attributed to routine inspections, repairs, or upgrades. It can be scheduled shutdowns as well. It can, you know, drastically improve the performance and in turn also prevent bigger issues. Uh, External factors which range from non-availability of raw materials to geopolitical issues uh, we had, which we were facing a few weeks back. These issues can halt operations altogether. Um, Now, again, system failures, malfunctioning systems can lead to a partial or a complete shutdown as well. So all these can be addressed as certain causes that can be mitigated using BIM-based processes and by adopting certain digital technologies, which I'll be talking about in detail. Now, why be keen on adopting such technologies? Now, the impact of downtime or shutdowns speaks for itself. Today, the often overlooked problem of poor industrial maintenance and unplanned shutdown can have ripple effects, especially to the manufacturing sector, and in turn affect uh, the economy of the company of a country it's altogether. So we'll be looking at certain digital solutions which can address these issues in the later part of this session. Globally, also certain industries or altogether industries are losing billions every year due to unplanned downtime. So maintenance issues are not just technical problems, it's also a business problem which needs to be addressed. Now, a recent study has also shown that unplanned downtime had cost Indian industries around 7 million per hour. And one of the most worst tragedies in which India has faced, which still haunts us till date, um, which is the Bhopal gas tragedy. And studies have shown that one of the main causes of this tragedy was improper maintenance of assets. So globally and locally, we do see such issues. These aren't just isolated incidents, they point to systemic issues. So why do we need to address these right away? It's simply because we can't afford one. The market size, uh, be it globally as well as locally also, it's poised to grow very much rapidly and quickly, with manufacturing output slated to cross 6%, or at least the targets are set at that. Uh, the growth statistics, uh, which is attributed mainly to Make in India initiatives also. So the industrial production is slated to become, increase year by year. The targets are set so, and in turn, it will have an effect on the GDP contribution as well. And also a lot of employment which is being generated. Thus, there is a lot of livelihood which is associated with the manufacturing sector specifically. And uh, now we have set certain goals here then. What are the challenges which is hindering uh, this digital adoption which we are talking about? Uh, while manufacturers acknowledge the importance of digital technologies, uh, maybe for profitability and competitiveness, most currently do not allocate that much amount, or they have a very less budgeted to such initiative. However, projections indicate that they'll be forced to have an investment to at least 15% in the next coming years, which will be focusing on huge technologies, including Internet of Things, which we call it as IoT for short, robotics, as well as big data. And a percentage of Indian manufacturers, sorry, have yet to develop a roadmap for digital transformation. So this indicates a lack of strategic planning in this area. Now, why this hesitation? It might be attributed to certain um, points or certain causes, which is like the perception is that high costs are associated with implementing such technologies. Maybe it's also a shortage of skilled professionals out there for specific technologies like IoT or cloud computing. Um, And one major thing is integrating new technologies or new solutions with the existing legacy systems that can be tiresome of some sort. And there is uh, a limited awareness on this. So this is something which at least we want to address in this webinar, which is to make aware of certain technologies which is being widely used, uh, so that we can leverage, so the manufacturing sector can leverage it specifically for their business solutions. And now, uh, the next part of this webinar will be focused on certain groups, which is specifically those who don't have a BIM strategy for their business in place, those who don't have a common data environment, which is CDE system in place, and those uh, who does not have a real-time centralized program or a digital twin in place. So these are the main focus. Uh, the people which we are on focus for the next part of the session will be these category. Now, uh, BIM or BIM, which we fondly call, there's a certain misconception amongst the general public that it is associated with some sort of a software. But BIM is not just about 3D modeling or just about a specific software. It's about streamlining the entire project lifecycle, right from design and construction to the handover phase and even the operational phase, which is where digital twin comes in. And what does BIM do? BIM leverages digital tools, a wide variety of digital tools out there in the market to improve coordination, reduce rework, and enhance the efficiency across teams. It also ensures that everyone is working from the same source of truth, leading to faster, smarter, and more cost-effective project delivery. So, how does this BIM approach make a difference? Now, the BIM approach supports seamless information flow across the entire life cycle of a project. So, right from the delivery stage to the operations stage, we have uh, BIM working all together. So in the delivery stage, uh, what we specifically do is we build intelligent 3D models. Now the specific word is intelligent 3D models, where you have geometry as well as data which is involved in that. So it's not just a 3D model, it will be should be an intelligent 3D model. It should act as a single source of truth. What can we use that for? For design visualization, documentation, construction progress tracking, and even do advanced simulations. While in the operation stage, uh, this same model uh, can be can evolve into a digital twin, which can support real-time operational insights, which can include equipment performance, occupancy, and even the overall asset health. Together, this integrated BIM approach ensures that all the project delivery and ongoing operations are well informed. It technologies out there which is evolving on a day-to-day basis and uh, which can mitigate uh, shutdown risks as well. So I'll glance through certain technologies which can be leveraged, um, starting with uh, Common Data Environment, CDE. It is it simply refers to a centralized um, digital platform used to collect, manage, and disseminate project-related data across different teams and stakeholders throughout the asset lifecycle. You have it's one of the key component in digital transformation initiatives. So what does these CDE include? It basically includes a centralized data repository where all stakeholders have access to the same version of information at any point in time. What does this do? This reduces data duplication and a lot of errors. And modern day CDEs also have um, sorry, uh, role-based access controls. Certain users will have access to relevant data based on their roles. So architects will have access to different types of information and engineers. So that's basically which we can assign roles and we can assign access to each and every stakeholders. Within most CDEs right now, we have version control and audit trails, so which can, live within a time frame, which can track changes and maintains records for accountability purposes. Uh, Also, within CD, also we have real-time collaboration, which enhances coordination between departments altogether. Now, model building, which is one of the most widely acclaimed uh, step in BIM adoption. Uh, it's also misinterpreted mostly by certain people as BIM, but it's only a part of it. Modeling approach, what it specifically does is helps create highly accurate and detailed digital representations of physical systems, which are actually built on site. So you can embed data into this live 3D model as altogether. Uh, what does this do? It ensures precise placement of equipment. It enables us to efficiently route certain maybe pipework or ducting, integration of support structures, and we can reducing the risk of clashes, and also in turn, prevent the costly on-site modifications. Additionally, it also facilitates for better project visualization, coordination among disciplines, and a smoother communication with all stakeholders. Ultimately, it leads to a better project efficiency and cost safety altogether. Now, digital twin is also a term which has been widely being used uh, since few years. So it's about bringing the site or drawings or geometry related data, bringing your bringing your operational data that is related to manufacturer, related to your vendor who's working on it, related to the warranty of a system specifically, um, other aspects related to maintenance, etc. Then we integrate the performance data. So we basically have a 3D geometry and operational data, and then the performance data, which is coming from the asset. Asset specifically, you can, like I've just mentioned, I'm just referring to an equipment. It can be anything from equipment or, a system. So integrating all these, uh, and when we bring all this together, it's now a living replica. Uh, so we can call it as an avatar of our project. So that's what we call as a digital twin. Okay. I also wanted to brush upon certain data capturing tools which we widely use, starting from laser scanning, which plays a crucial role in preventing shutdowns, specifically in complex manufacturing environments, uh, where accuracy, planning, and speed are critical. So in short, I think accurate as-built data is equal to a better planning. So laser scanning, that what it provides is highly accurate data which can be later processed to build 3D models. Uh, so what's its impact? So retrofitting, from a manufacturing perspective at least, retrofitting, maintenance, or expansion projects can be planned precisely without any assumptions altogether. Um, and this can help in avoiding clashes or any surprises or rework that would force a shutdown. Um, and next one is also related to robotics as well as drones. So one critical area where drones are widely being used right now, it's in the power plant sector, where remote inspection of at least critical infrastructure projects. So drone inspect um, hard to reach areas like roofs, tanks, chimneys. I think we even have drones which are inspecting wind farms, which is for maintenance purposes. And thermal imaging drones can also detect overheating of motors or electrical panels before its failure, enabling predictive maintenance. Then construction and retrofit progress monitoring uh, is also one key area where drones are being widely used right now. Drones can quickly access hazardous or contaminated areas to assess situations. For example, you know, comparing drone captured progress against a BIM model ensures construction aligns with the live operations. Uh, Drones can also reach where normal human beings can't. So they can quickly access hazardous or contaminated areas to assess situations. It also helps in fast decision making in case of emergencies altogether. Um, uh, and in short, drones enhances visibility, safety, and speed, helping manufacturers detect issues early, maintain continuous operations, and thus avoid uh, very costly unplanned shutdowns. Um, Again, coming to robotics, which is also like uh, inspection drones, AGVs, and even robotic arms, which are equipped with sensors, which constantly capture machine performance data. Uh, so this data is streamed live into the cloud where it is analyzed on a real-time basis. This helps in faster and remote inspections. Sensor data from a wide robotic range of robotic systems feeds into cloud-based digital twins. These twins can simulate wear and tear, failure points, and efficiency drops. So what is its outcome? It's simply that operators gain a full visibility of into the asset health and intervene before any downtime is needed. So that's the proactive approach to certain aspects of it. Um, in short, robotics captures, uh, cloud stores, and analyzes the data, and the data enables action of some sort. So all together, all coming together to keep the facility running smoothly and efficiently without any surprise downtimes. Now, coming to the visualization part of it, at least out there, like uh, we have been widely using AR VR simulations, where one part is the training part specifically, like technicians can be trained on specific maintenance tasks without needing to shut down the live equipment as altogether. So, and also AR headsets can also relay real-time data, instructions, and diagnostics directly to the physical asset during shutdowns, during a plant shutdown specifically. Um, so this, what it helps here is it improves decision making on the floor and reduces downtime caused by uncertainties or delays, and enhances the first time fix rates. Um, Now, experts who are not available at site can also join shutdown operations remotely using AR, guiding the on-site teams through complex repairs or inspections. These are like the wide variety of use cases in which AR VR sets can be used altogether. Now, how will digitalization and its adoption of technology bring in savings altogether? That's the golden question here. Now, savings will always be a byproduct of elimination of duplication of efforts and its transparent data and the processes that can now analyze the data, right? So I've just used this graphic in a way in which it's understandable to everyone. So in the context of shutdown manufacturing. So by shifting from traditional drawings to intelligent 3D models, again, intelligent being the key word here, digital simulations, uh, and adopting certain workflows, we can start with accurate and analyzable data. So this means any intervention, uh, whether it be maintenance, retrofit, or even an upgrade, is based on real world conditions and thus reduces the risk of errors or rework that can lead to a major shutdown. Um, Tools like LiDAR scanners, which is laser scanners, drones, and robotics, replace manual site data collection and reduces the chance of miscommunication and also data loss. Um, Thus, less reliance on human input means faster, safer inspections and early detection of risks. So issues are addressed proactively without halting any production altogether. Then establishing a transparent organization where CDE plays a huge role, where you have a single source of truth um, for all stakeholders from operations to maintenance. They are all on the same page. This visibility across departments ensures that maintenance and upgrade plans are coordinated and clash-free. So thus avoiding shutdowns caused by last-minute surprises or even siloed decisions. This entire digital pipeline from capturing reusable data to driving intelligent decisions enable a proactive, connected approach to asset management, dramatically reducing the risk of any unplanned shutdowns. With this, I'd like to conclude this session and maybe take in a couple of questions.
We'll wait for 2 minutes. If
Yeah,
anyone
sure.
has any questions, they can let us know. Okay, so we have one question. Remy, how do you differentiate between a planned shutdown and an unplanned one? Beyond just timing, it's about control, communication, or is it about preparedness?
Okay, how do you differentiate between planned shutdown and
Yeah,
an unplanned one? Okay. Is it about control, communication, and what was it?
preparedness.
Preparedness. Okay.
Yeah.
So great question put forward. Uh, I think, well, timing is the most obvious difference between a planned and an unplanned shutdown. Uh, I think the real distinctions are much deeper. It's touching on control, communication, and preparedness and the impact of it. But altogether, I think when it's a planned shutdown, at least like we have it's scheduled, there's like a proper communication which is happening. We prepare for it. It's also data driven specifically, so we know all the data, and there is a minimized risk of within a planned shutdown. And when it comes to unplanned shutdowns, it is a reactive one. It's out of the blue. You have some data which is coming in, and then you have to make up certain decisions. So that implies like poor communication, and the lack of preparation is also comes in. And obviously the cost factor comes in where like a huge mm, cost is associated with unplanned shutdowns altogether. So the true difference lies in the level of control, I think, in terms of coordination, then communication and the readiness. Planned shutdowns are proactive, while unplanned ones are reactive. You can summarize it like that. And the cost in both in money and operational impact reflects that. Yeah, hope that answers the question.
Thank you so much, Preeti. I'm pretty sure their doubts were solved. So if you have any other questions, please let us know. You can raise your hand or you can text them. Your phone. Okay, so we have another question. Remy, is a shutdown always a sign of failure, or can there be a strategic advantage in asset-intensive industries?
Is shutdown a failure? Hmm, not always. Uh, in fact, certain industries, it's a boon for certain industries. A well-planned shutdown can be what do you call a strategic advantage altogether. So when shutdowns are strategic, it's like preventive maintenance or like planned shutdowns also allow time servicing overhauls and inspections, preventing future failures also. So it uh, helps industry to rewrite all those uh, SOPs of some sort. This is maybe in specific cases altogether, but it can be a boon sometimes. And when is it a failure? It's a failure when you have poor asset monitoring, or the lack of skilled workforce, or even the lack of digital readiness, which the data which is not present at that time, and obviously inadequate maintenance planning altogether. So in short, like uh, a shutdown isn't a failure. It comes only when it's unplanned or unmanaged. In the right hands, a shutdown can be a strategic lever for performance, reliability, and even for growth. Yeah. So no, it's a boon altogether.
I think that was a very elaborate answer that you gave. So I'm pretty sure everyone's doubts are also solved. I think those were the questions. Okay, we have another one. What technology is most important and involved more here? Like, is it BIM, sensors, getaways?
What technology is more, sorry?
Which technology can be more relevant, which is more important
Mm-hmm.
with
Uh,
respect to industrial shutdowns?
which technology is more relevant? Okay.
Yes,
Uh, the relevance based, I would say that adoption of technologies is the most relevant one, whether it be BIM, whether it be uh,
sensors.
robotics, sensors, use of sensors, but the will to change or adopt certain digital technologies which will help businesses is quite important. I think it's not just the technology adoption, but it's the will to change those and come forward and then adopt certain technologies. So yes, correctly, like BIM can help you a lot in certain aspects of it. Certain other technologies you can also leverage, but make sure that the implementation is done correctly, which is also data driven, and everyone should be able to collaborate uh, promptly on such data driven choices.
Right. That was, I think, that's about it. Thank you so much for your explanation, Remy. And thank you everyone for your questions. I think the questions were also very curiosity generating, and everyone has learned a lot from today. And I'm pretty sure this webinar has also offered a new, fresh perspective to everyone in this industry. So we appreciate everyone who has joined us today. At Digitra, we are committed to helping you lead smarter, more efficient industrial operations through digital transformation. Don't forget, we have some very interesting sessions coming soon. Stay connected for updates, and as always, feel free to reach out with any feedback. Thank you once again. Thank you, Remy. Thank you, everyone.
Thank you, Purvi. Thank you, everyone.
Thank you.